Thank you all. Thank you all so much for having me here, and thanks for coming back after lunch. I know that's the hardest part, so I'll try to keep the energy up here. So really building off of a lot of the conversations that we were having yesterday and today, you know, I think in some ways I originally intended for my talk today to kind of close the loop on some research I had started back in 2020 when the world kind of hit the big pause button for a while. But you know, I think the more I kind of got into this, the more I realized actually that I'm just asking more questions and posing more kind of creative and research questions than I ever thought possible. So I just really want to thank you all for kind of giving me the space to kind of work through this and think about what will come next through the process. So before I jump into things too far here, I want to start off by kind of looking at some of my old work to provide some context. Here we are. So I want to start with this photograph I made in 2018. It's 18 reds for my teaching classroom. So I want to start by asking a seemingly simple yet kind of complex question. What is red? You know, I asked, so this is a composite photograph I made by taking 18 photographs, one of each computer in my teaching classroom. You know, I kind of programmed my teaching station to say, this is what neutral gray should look like. I used that as a reference, and then just put around and then asked each computer to show me, all right, this is what it thinks red is, 25500, red, pure red. This is what each computer thinks it is. And kind of this is what I got. Not, you know, kind of not what I was expecting. But kind of it really made me really kind of dive into some of these questions about thinking about, you know, we say we're looking at red, but really there is this nuance and this kind of invisible conversation that's happening between the computer, digital standards, color theory, and even natural language and how we describe color. So this is something that I've been seeing kind of as a continuing kind of trend and theme in my research. So if I drive back a little farther here, I want to go back to a photograph I made in 2011, kind of in the early days of Google Art Project before it really kind of became Google Culture. And I was just like taking a tour through the Tate Britain one day and found that I could actually look at Chris O'Phillius' piece, No Woman, No Cry, but I can turn the lights off and I can see it glow in the dark. The painting glows in the dark. I was actually just at the Tate this weekend. They make no reference to the fact that the painting glows in the dark. Without this kind of new way of seeing, kind of without kind of this new experience beyond the traditional viewership, I'd have no way that the painting glows in the dark. I'd have no way of seeing that this is the underlying image. It's not going to let me in at night, right? If any of you can bring me into the Tate after dark, please let me know. I think that would be just kind of a really fun viewing experience. But it really started at making me ask these questions about kind of what does technology let me see? What does technology not let me see? Kind of what becomes visible and what becomes invisible. So I spent a lot of my time on my research over this last decade in my own creative practice, really thinking a lot about kind of what do we gain by technology, but also kind of, and to kind of thinking about what we gain by technology here, kind of this image on the right. This is a photograph from the Harvard Art Museums where they have these really damaged Mark Rothko paintings that basically are they're not unseeable, but they don't look anything like they're supposed to look anymore due to sun damage. So what they did was they actually, through the original slides, which was a whole process in itself, then digitizing old Kodachrome and trying to figure out how that faded over time. They were actually able to reconstruct what parts of the images the paintings were faded and lost, and then projected them back onto the original canvases. So again, we're kind of using technology to show us something new, show us what's gained that we can't get out of the normal viewing experience. And we can kind of see the white card, so we can see what's faded and what's being projected. But then on the other hand, we have a lot of works that can't really actually be seen or experienced digitally. And that's really kind of this idea of loss, of what we lose in the process, is kind of where I'm really interested right now. So it's thinking about Yves Klein and kind of these deep saturated, really experiential ultramarine blue color that he works with. Can it really, my research question was, can it be seen digitally on modern screens and digital devices? Or is there just experiences of viewership that are completely lost, that no matter how hard we try, we just can't replicate, and ultimately just creating something new unto itself? So why Yves Klein? And really the reason I like working with him is because he basically is known pretty much for this color, International Klein Blue. It's a color that he developed working with a French chemist, Edward Adam, where basically he combined a very specific ultramarine blue pigment alongside a very specific resin-based binder that did not actually alter the structure of the pigment in a way that allowed him to really kind of, when it mixes when the colors kind of mixed, it kind of became pure energy and created this visceral experience transcending the canvas itself in a way that when he mixed with other binders, he was kind of said that the effective magic of the color vanished. So it's Yves Klein. You know, what's really interesting about his work as well is that he had a relatively short career making these paintings. The first monochrome paintings that he created were exhibited in 56, 57 thereabouts, and he died in 1962. So that gives us a very short time frame of works using this very specific pigment, this very specific binder that ultimately should give us some sort of stable idea of what this color is supposed to be. We think, we hope, maybe. And so this is really where my research began. And what I did in 2020 was, as the world was shutting down, I wasn't really able to get to museums and look at his work. So I started looking at a lot of copy slides of his work. And this is a paper I published in 2020 that I wasn't able to present upon. But really what I found was that by looking at different copy slides of his work, by just kind of whatever I could find on the internet, so a lot of images from auction houses, a lot of images from the Yves Klein archive, wherever I could find copy slides and images of his work, I was looking at them and I was trying to figure out how close in color they all were to each other. And really the high level is that the colors varied widely, and that even though that all these images are supposedly of his paintings and all of his paintings are supposedly the same color, none of them actually were. There was a lot of, you know, we found some consistency throughout different archives. So it's like a lot of the Yves Klein archive images look like each other. You know, a lot of Christie's auction houses had images that looked like each other. But they all, when you put them all in a grid, they all just kind of are all over the place. So I started really thinking about, all right, yep, I have to do a better job at understanding this. So what are some of the things that I couldn't control for in when I was looking at copy slides? You know, I had no idea of how the copy slides were originally captured. I had no idea kind of how the images had been processed, any of the technical things that we're really kind of thinking about and want to build consistency into. But really the biggest problem is I had no actual reference of what International Klein blue, of what this blue color was supposed to be. You know, I had all these copy slides and I could make statistical averages of what I thought it was supposed to be. Turns out I was pretty wrong on that. But luckily last year I was invited by the San Francisco Museum of Modern Art to actually view some of the Klein works they had on display. So they had one of his blue color field paintings. They had one of his anthropomorphic paintings, which he was actually using the same pigments, the same materials, but actually using bodies as the paintbrush. And then also two of his sponge works. So these are actually the same pigment, the same binder applied onto sponges. Yeah. The one on the left, I do want to point out while we're here, the one on the left matches the other two works, while the one on the right, you can't really see it here, but there actually is a bit of a visible color difference, which you can actually see it to the eye. And we think it's because there was some prior pre-accession conservation that had happened to the piece, but because it was pre-accessioned into the SF MoMA's collection, we don't really know exactly what was going on there. But so really, with these works, along with last summer when I was here in London, I broke into the Tate and the Tate Modern, which had Yves Klein up, and I used my little ray gun to, here we go, my little color sensing ray gun right there. It's a great party toy. What color are you wearing today? But anyways, I was able to actually take readings of that as well, just kind of looking around. It's a camera, don't worry about me, I'm fine. So what I did was I was able to take these accurate, hopefully pretty accurate measurements of what Yves Klein's paintings actually looked like in a gallery condition. So I'm not taking these off the wall, bringing them into a lab, going somewhere else. I'm really interested in understanding, how bright, what the colors look like in the traditional gallery viewing context, because that's ideally how the viewer is going to see the work. So what I did was I made these measurements. I then converted them using a lot of math, even more math, and then even more math that I won't bore you all with. But the idea being is that I could take these measurements, measuring both the brightness and the chromacity. So kind of as we think about the different kind of colors, we have this idea that along the outside of the locus here, these are all the wavelengths of visible light. And then kind of this is within this diagram, these are all the colors of light that the human eye can see. So the idea is that kind of within the spectral locus, I can locate where international Klein blue lives, and then bring it into kind of how different ways that computers and we can process and describe color, and then run some tests to see how accurate it all is. So what is this? Why did I do this? What does this all mean? This is like a lot of math, and I'm an artist. I should not be doing math. Let's be honest. So really, what did I learn? I learned that the delta E, so there's these formulas that we can use, delta E formulas that tell us how accurate colors are to each other. And kind of the delta E score is underneath 1. It's not, difference in color is not perceptible to the human eyes. 1 to 2, perceptible through close observation. 2 to 10, perceptible at a glance. There's this idea that between 1 and 2.3, I kind of put 2.3 in small and italics because when you ask, that number may or may not be the same or different. We have this idea of just noticeable difference, or this idea that if I just glance between 2, I can see a difference in color. 11 to 49 colors are more similar than different, and 50 to 100 colors are more different than similar. So kind of polar opposites on that, on those color plots. So the idea being that of my physical observations of the works that I saw, the data from observational measurements was such that the delta E was under 2. So that was actually, that told me I was getting really good data for the most part. And then the one outlier actually was at 4.56, but that was the one that we think was conserved. So that even though if it in the conservation studio, it might have looked perfect, in the real world, under gallery lights, again, like tungsten lights, things aren't quite perfect in that way. And then kind of when I revisited the images that I was discussing in the 2020 paper, 70% of the copy slides had a delta E greater than 10, which means the colors, well, they're more similar than they are different. They're still more not very good and not very close. In the paper, I really thought that because they were so close together, Yves Klein's archives had the best color rendition. Turns out the Yves Klein copy slides were not very good, and the best copy slides were actually the ones produced by Christie's auction house. 50% of them had kind of this value under 10. The best was 4.7, which was right around that same number as the conserved painting or the conserved sponge, which I thought was really interesting. So why do I care about all this? Really, this is like super esoteric and deep. Why do I care about this? It's because I want to know if I can see this color. Can we see this color digitally? And as much as I want to say, yes, we can see it, no, we can't see it, it depends. Everything in color is all relative. How hard we try to make it an absolute. So I have to think a lot about kind of the accuracy of the data, the accuracy of the capture, relativity, kind of how do colors work next to each other? And then what's the use and intent of the work? And then really the big question that I now have to kind of wrestle with on my own is, what does it mean if we can't actually see this color? And what we can see here, so it's kind of as we plot all the colors, again, that the human eye can see, the samples, the 4 good samples I have are kind of all in this dark range down there. And they're in real life, they're a lot darker than this. This is just kind of the way the plot decided to present itself on my laptop. So to know if we can see the color, we have to think a little bit about how computers process color. So all computers process color through this idea of red, green, and blue, that by combining some element of red, green, and blue, I can create all the colors that we can see. But the problem is we have to go ahead and define, or the technologies have to define for us what those red points are, what those green points are, what those blue points are. So, you know, if I'm working with kind of what we think of are really constrained color spaces, something like sRGB or Adobe RGB, you know, most devices naturally pretty much are going to be able to represent the colors of sRGB. Now, I think more so Adobe RGB and some other color spaces like HDR, P3, all the fun buzzwords we want to throw into our devices now. But really, it's still a really small range of colors that when we define what those red, green, and blue points are, that can be represented. Now we have other color spaces that can show us a lot more colors. Row photo over here is kind of really interesting, along with a lot of others, is we can see into those blues. We can see kind of really down into this space. But what happens is it falls outside of the range of visible colors. So we're actually we're actually making these computational colors that the computer can see that we can't see. So it's kind of this really interesting point for me there too, that I always love to play with in my art, in my own work, is how do we represent colors that we can't see? So knowing all this, what does that tell me? It means International Klein blue falls outside of the range of colors that we can see, that we can represent in sRGB. Kind of we can see on the left in the 2D plot that I made these fun 3D graphs. It falls outside of the shape of the colors that we can see. Same with Adobe RGB. International Klein blue falls outside of the spectrum. So it gets enveloped inside ProPhoto because ProPhoto can represent most anything. Then there are other color spaces that really can, that were designed and developed to represent everything. So why do I care about all this? And kind of really, for me, at the end of the day, this really, as a case study, it illustrates a lot of kind of, as I think about photography, as I think about digital imaging, as I think about where do I take my practice next, you know, what are other paintings that are digitally invisible? And what does that mean? Does that mean that we can actually have a museum where we can actually never show the work digitally and kind of create some really interesting visitor interactions through that? How can I make paintings or make sculptures that, as much as they look really interesting in person, when photographed, they just look all singular one color because we can't actually digitally represent or capture those colors. You know, kind of, again, thinking a lot about how I can exploit this in my creative work. And are there ways that, you know, kind of, what does this mean for museums? You know, if we're trying to capture and preserve and share all this work, if we can't actually see these colors in the best of intentions, how then, where do we go from here? And these are questions I do not have the answer to, nor should I probably be the one to have the answer to, but it's kind of, I think, those things that kind of keep me up as an artist. So with that, thank you all very much.